So my inverse is 3x minus 6. So here we have our original function and our inverse function. Now to check our work and to verify that they truly are inverses of each other, we're going to use our definition. So we're going to take, and I'm going to go ahead, we had this one named as f of x. I'm going to go ahead and name our inverse g of x. And again, using our definition, I'm going to find, first of all, f of g of x. You remember from our composition of functions, that means that I'm going to take this entire equation and plug it into our f equation. So I will have 1/3. Now in place of the x, I'm going to put this whole equation here. 3x minus 6. Okay, let's go ahead and work through that one. So 1/3 times 3x, we get 1x minus 2 plus 2. We got back to an x. That was what we wanted to do there. Now the next thing we do is we're going to go the other direction with it. We're going to find g of f of x. We have to undo each other. So let's take our entire f equation this time and plug it into the g function. So this time we have 3. We're going to take the entire f equation and plug it in for x. So that will be 1/3 x plus 2 minus 6. Go ahead and distribute again. And sure enough, we're back down to x. They are inverses of each other. So the process of finding an inverse, where we have x and y trading places and then we solve for y, gives us, that's the process of finding the inverse. Now this is the process of verifying that it truly is the inverse and that I did it right. So I can check my work and verify that they are inverses of one another. Now, this whole idea of the x and y trading places gives us something to look at as far as the graph is concerned. So not only are we going to look at inverses in algebraic form, we are going to look at the inverses graphically, which is kind of what we've been doing all the way through our study of functions, is we've been looking at things graphically and algebraically, both. So I'm going to take, let's just work with this graph to start with. I want you to see what this looks like. Basic graph. Can't see that very well. This first equation is g of x equals x cubed. So this graph right here, I'm going to go over it. Okay, so we have g of x equals x cubed. And the inverse for that equation would be the cubed root of x. Okay, so these are our two equations. Now, what happened when x and y traded places is that what used to be on the x is now on the y-axis. What that does for us is it gives us a reflection over the line y equals x. Y equals x, they traded places. So what happened is we get this reflection. They are reflections of one another over the line y equals x. So, for example, you can't really see this very well on this one. I'm going to come out, if I were to come clear out here to 2, if this continues to grow, at 2 cubed would be 8. This point way up here is located at 2, 8. And if this one continues to grow, the reflection of it down here, this point then, located, is at 8, 2. Notice the x and the y have traded places. They're reflections of each other. There you go. Now you can see it. So we have the reflections. So we can look at it algebraically. We can look at these things graphically and see inverses of each other. One of the things that, and I can show you here, when we're talking about inverses and notation that you should be familiar with is, I'm going to come back to one of our inverse functions that we did. Pull this one back up here. This is the one that you worked on. Inverse functions, notation-wise, quite often you will see listed this way. If our function is f of x, then our inverse is listed with a -1. This symbol just means inverse. Okay? So that you're familiar with that symbol. They'll ask for an inverse using words, but you'll also see it with the symbol. So be familiar with that symbol. And on that graph we just did, not sure how clearly you can see that, but it is listed as g to the -1 of x. That means the inverse of g. Okay? So we have some symbols, we have our algebra, we have our graphing. But one little caution here. Our caution is that not every function has an inverse. Make sure you write that down. Not every function has an inverse. And I'm going to look at it graphically before we go into any more detail on it. But graphically, let's see if we can understand what that means. So let me give you an example. There's a parabola. And if we were to draw its inverse, we're going to use our idea of the reflection over the line y equals x. Okay? So when I draw the inverse, let's just look at it graphically to start with. When I draw the inverse and then I check to see if my inverse is a function, my inverse didn't pass the vertical line test. So I do not have an inverse function. Now, rather than go through the whole process of looking at our graph, drawing the reflection of it, and doing a vertical line test, there's kind of a little bit of a shortcut here. It's called the horizontal line test. So if we have a graph, we don't have to draw the inverse of it. We can do a horizontal line test and see that we have two values on the horizontal line, not just one. That means that we don't have an inverse function. Similar to the vertical line test, this is the horizontal line test, and it's to determine whether there is an inverse function. Now, let's look at one that does. And we'll take a very simplistic one, but let's go ahead and take a look at just a straight line, linear graph here. Draw the reflection over the line y equals x. So my original function passes a horizontal line test. When I look at the inverse, obviously it passes the vertical line test. So this is what we call a one-to-one function. Okay, one-to-one function. It's a function that does have an inverse function. It passes our horizontal line test, and you can see that it passes our vertical line test. Horizontal, 1 point at a time. Vertical, 1 point at a time. And we'll go into this in a little more detail in another section, I believe. But for this section, in general, what you need to know is how to find an inverse, how to verify the inverse, what the inverse looks like graphically, and then some quick little tips here on deciding whether a function has an inverse function or not, that horizontal line test. Okay, so your teacher has an assignment for you dealing with inverse functions. Good luck with your assignment.